recording. Okay, couple more minutes. Let me get my smart notebook rolling here. Okay. Write a little bit on here. Oops. I think I need to do my thing here. Antiderivatives. Old and new. So that's our focus, gonna be our focus for this morning. Good morning, everybody who's here. And those of you who are joining. I'm guessing, like students in my AP classes, you're gearing up heavy right now for AP stuff, given that AP testing starts next week. I know the Gov test is Monday, I think. So that's probably your main focus right now, and I totally get that. If you're going to miss class next week because you've got well, I guess you don't have an AP exam Thursday morning, but if you're prepping for an AP exam or something, that's fine. Just let me know this coming week or the following week. Good morning, everybody. I'm assuming your AP teachers have shared tons and tons of stuff with you. Like I have with my AP classes. If for some reason you're not, or you don't know what I'm talking about, you're like, what? I mean, there's a lot of things about how you're going to take the test online. You should, when you're getting emails that are going to have your test tickets, or your test login information, because you'll get one for every test. I think 2 days before. There's a practice login and a practice thing. You can practice uploading your answers. Probably not a big deal in other classes like it is in math, because in math we're doing a lot of handwriting and pictures, where I think probably in the other ones you're guys are going to type. But anyway, I just want to remind you, just if you need AP related information and your AP teacher for some reason isn't getting back to you or whatever, you can always come to me, because I've got all the basics, and I'm a nerd, so I just have it all organized and everything. So if you need anything AP related, let me know. I'm here to back you up on that, because just like I said, for my students, for all of you guys, I want you to be able to finish what you've started with your AP classes. Okay? And I want you to be able to finish, in some regards, what you started with me in calculus. And so our last few weeks together, we're going to shift our focus on antiderivatives for a couple classes. That's where we were, and we would have done a lot more with antiderivatives. We're going to do some of what we were going to do, little snippets of it, not all of it, obviously, because it's not as easy to do online and in these shorter sessions. So, but my goal, as it has been the whole time since we've left school, is, and even when we were left school, I mean, my goal for you is to walk out of this class with some basic calculus stuff, so that if you take a calculus class again, you think, oh yeah, I remember that, or I remember at least I learned it. You might think you're not going to remember anything, but you'll be surprised if you do take a calculus class at the college level, how much having had exposure to it here in high school will help you. Okay? So that being said, I've got chat on. Yeah, I do, right? Let me double check. I mean, I can chat. Yes, so chat is on. So if you have a question that you want to type in chat, you can do that. Or if you want to ask a question, you can raise your hand with the little raise your hand guy, and then I will give you a mic to do that. So So let's go ahead and go. Let's talk about antiderivatives this morning for a little bit. It feels really early, but like we would have been almost done with second period by now. So it's hard to remember that, whoa, we used to do this in a lot earlier time. Okay, sorry. Kind of get distracted here because I hear my child upstairs being a cuckoo. Okay, so here we go. So what I'm going to do, also a reminder, I'm videoing this or I'm recording the session and I'll save the notes kind of like what we do in class. I have my same little smart notebook set up. So let's roll. Okay, and you may hear a lawnmower outside because we're live. Okay, antiderivatives. Antiderivatives, we know, or we learned in the second half of the course. We had a sign that looked like that. It was the integration sign. Okay. And also was a sign that we used just to calculate something called the antiderivative. Now, the way we used it depended on if we had numbers on either end or not. An integral with an area, and we learned about the integral and integration and calculation of areas. And then we learned about an antiderivative, which is like undoing the derivative. And then we realized that those two things were going to be connected. So let's just focus on the undoing the derivative part. We'll review what we already learned about it, how to find an antiderivative, and I'm going to show you a couple new ones today, a couple new functions. And we got to switch our heads here now because we've been doing derivatives. If I'm looking for the antiderivative of a polynomial function, or a sum or a difference of polynomial power terms, I guess is a better way to talk about them, that we have sort of a reverse of what we do for a derivative. When we take the antiderivative of ax to the n, we get x to the n plus 1, so we add 1 to the exponent, and then we divide by that new exponent. Okay. So my antiderivative in this case, hopefully and this should be good, you could work along with me, that would be a good plan, piece of paper, pencil, fun stuff. 5x cubed over 3 plus 3x squared divided by 2 plus constants. Just add on the variable, and that's what this part is. It's just telling us what variable is in our antiderivative function, and then plus c. Because we realize if we take the derivative of this expression and get here, there could have been a constant that we don't know about, that we won't see in the derivative. Oftentimes we need other information, and we did that as a set of problems as we talked about how to find the antiderivative and then take additional information about the function to calculate the c. Okay. So this is our old stuff, and we had a couple kind of variations or just little tricky things on that. So we kind of throw a few of those up here and see what you remember. Pretty much what made antiderivatives a little extra tricky sometimes was the exponents. Okay, so if I had something like 4x to the 1/3 dx, the process is still the same. The rule still gets followed the same way. It's 4x, but when I take 1/3 and add 1, I get 4/3. I have to divide by that fraction, then there was a certain cleanup element to that. I didn't want you to leave complex fractions. So dividing by 4/3 is like multiplying by 3/4. And so this kind of cleans up like this. So it wasn't that the calculus was different. It was that you had some arithmetic to do, some fraction-based arithmetic, adding 1 to 1/3, dividing by that result, which is 4/3. That's the part that kind of may have not made it harder, just made it a little bit more challenging. Other things that made this challenging, just kind of reminding you, how about if that was a negative? Okay. So we have the same fraction issue. We're adding to a fraction, but we're adding to a negative fraction. So we've got the whole idea of a signed number that makes it a little tougher. Okay. Go ahead and do that one. Negative numbers in general. I don't know why I'm obsessed with 5s today. How about 7x to the -2? I don't think negatives were too hard, but still always can be a challenge to deal with a signed number. And third thing is if you have something written like this. Oh, not like that. That's not what I meant. Like this. The algebra that you need to rewrite that. Okay. Go ahead and do these 3 real quick, and then I'll do them. So if you want to try those 3 in just a second here, I'm gonna put a timer on, gonna put a timer on. Let's do a little 2-minute timer on that. I don't even think you need 2 minutes, but let's do those 3. Hopefully, since we've heard some things from the governor this week about trying to get some stuff open in Virginia, we'll be able to do a little bit more in groups and things. I'm kind of holding out hope that maybe in July or maybe at some point we'll be able to look at you guys again and see you guys again as a group. I don't know when that's going to happen or if it's going to happen, but I'm going to keep my fingers crossed that will happen. That we'll have or at least we'll have the opportunity. I don't know that everybody will be available, obviously, to do that, but I will. I would definitely show up to something in the summer to see you guys for sure. Even if we just have to do it at Westfield in the parking lot, I would totally be there. Being super excited. Going, woo! We can just walk across the parking lot. Not quite as cool as, I can't remember what it's called now. It's not the Patriot Center. M&T Bank Arena. I don't know. Whatever it is. I still call it the Patriot Center. It's not as quite as cool to walk, but fun. It'd be fun to do in the football field. Do it outside. That's how I graduated. We always graduated outside. So my brother, it rained, and so he had to go inside in our high school. So every school's different. I know it's kind of it's a new tradition. You guys will be special. Whatever you do will be. I mean, you're already special, but it'll add to it, and you'll talk about it on your reunions and stuff. Okay, so answers. Let's see. How about 5x to the +1/2 divided by +1/2 plus c, which will come back to 10 x to the +1/2 plus c. Okay, if I'm dividing by 1/2, this will be like 2 times 5. Dividing by 1/2 is multiplying by 2. This guy, look, I'm trying to color coordinate here. would be 7x to the negative 1 over negative 1 plus c. Lots of different ways to write that. Okay. Most of you guys would leave it like that. Some of you, though, might, and this is where you got to be tricky. The 7 doesn't go in the denominator. You can do, it's going to be a 7 and then negative x plus c. And then this guy, you have to know kind of the reverse of what we did to change the answer in the blue problem. In this problem, that 10 over x cubed is 10x to the negative 3. So my antiderivative to that would be 10x to the negative 2 divided by negative 2 when I add 1. And so, oops, negative 5x to the negative 2 plus c. So our basic rule works great with one exception. And we've kind of just not ever talked about this exception, I don't think, or if I may have mentioned it, where this is an awesome formula. It's not perfect. I'm going to grab it just so I can. All right, there it is. So what's wrong with this formula? This formula has one limitation. Only if x does not equal, oh, not x, I'm sorry. It's not, x is not the problem. The problem is n. N can't be negative 1. If n is negative 1, then this formula does not work. And you're like, well, why not? Well, watch. And it doesn't really matter what number I put for a. So I'll put my 5 since I'm in love with 5s today. So that would be 5x to the 0, if I add 1, divided by 0. No. You know, that makes the earth explode. That's probably why we have coronavirus. Somebody divided by 0. So dividing by 0 is not valid. And so this trick, this process, only works if n does not equal negative 1. And so hopefully then, that would then create the question then, so what do I do with something like that? Well, that's one of our new things for today. Now, if we're taking the antiderivative x to the negative 1, that means we're taking the antiderivative of 1 over x. And so there's not really a good intuitive way to kind of get to this. There's not like I can show you why this is going to work this way, but what you have to know is you have to know the function where the derivative of f of x is going to be 1 over x. Okay. And that function that we reviewed a couple classes ago is the natural log function. And so when I take the antiderivative of 1 over x, the result is the natural log function of x, but we throw some absolute values around the x because the natural log function is only defined when x is positive. And so, well, the argument's positive, so the absolute values will do that, keep it positive, plus c. That's a new rule to add to our toolbox. We've got the backward power rule that works great on all polynomial type power terms, x to any power except negative 1. When I have x to the negative 1, the resulting antiderivative is the natural log function. So you might see it like this, or you might see it like this. And you have to go, oh, that's that special guy. That's the natural log. Like I said, not intuitive in any shape of the imagination. Okay? Not something you would go, oh yeah, totally. I totally understand why that's the natural log. Okay? But that is going to be the rule. And usually what will happen is you may not remember that rule, but when you start doing backward power rule on something with a -1 power and you get to the point where you divide by 0, you go, whoa, wait a minute, that's wrong. And then you remember, oh, there's some other special weird thing. Oh, it's natural log, my favorite function. The other stuff around it works the same. So, like, if I had 4x plus 3x to the -1 dx, and I was asked to do the antiderivative, each piece would treat separately. And so this would be 4x squared over 2 plus 3 goes along for the ride, but that guy is that, and we throw the plus c on. And so 2x squared plus 3 log absolute value of x plus c. Okay. Extra numbers in the front work the same way. If it's added or subtracted to other pieces, we treat the other pieces like using their rules. This is the only special one. It's either when we have it like this, or we have another way to write this, maybe in the problem, might be 3 over x. Okay. So we have to watch for it in this format. This format, I think we're more likely to start and eventually get to the natural log. This is the one that we get tricked on sometimes. We also get tricked sometimes, now that we know that, is if I do something like this, there I am with those 5s again. You guys go, oh, I know how to do that. That's a natural log. Nope. Not with an x squared down there, not. It's not. Okay. Because if I rewrote that, that would be 5x to the -2. And then I could just use my rule. And I could rewrite that if I wanted to. So that's sort of the flip side of the natural log, is sometimes you get natural log happy. And so that anytime we see a quotient of any kind with any kind of power down here, you go, oh, I'm going to do a natural log. And it's not necessarily a natural log. Okay, so new rule. Our natural log for x to the n when n is -1, or for when we would have a 1 over x term. The second new guy that I want to teach you today, okay, is how our friend e works. Okay. This is the part where I write this down and then I laugh because I try to make that not look like an S, but it looks like an S. So, okay, just say, yeah, we talked about sex today. No, we talked about the antiderivative of e to the x. All right, so the antiderivative of e to the x, well, think about the derivative of e to the x. You're like, well, I don't remember. E to the x is our favorite derivative because the derivative of e to the x is just e to the x. And the antiderivative of e to the x is also just going to be e to the x. So e to the x is super fun to take the derivative of and to take the antiderivative of. Now, when we were doing our derivatives, if we had something like e to the 4x, my derivative would be e to the 4x times 4. If I'm doing an antiderivative of something like e to the 4x, that's going to be e to the 4x divided by 4. All right, so that's the difference in how the E works. We can kind of prove that a couple different ways. We can look at a couple different examples. I actually would have taught you this a different way because I would have taught you some other stuff first. I'm sort of just trying to shove E in here so we could talk about how to work with an E. But this is a pretty good beginning with E. This doesn't really cover every potential situation about an E function and an antiderivative, but it gives you a beginning. So the antiderivative of e to the x is e to the x. The antiderivative of e to ax is e to the ax divided by that a. So you don't change the exponent, but there is a division portion. So you don't add anything onto that. That's the part you're like, oh, should we add one? No, e kind of does its own little thing. Okay. All right, so I'm going to give you, so here's what we're going to do. I'm going to give you 3 more problems to practice. I'm going to give you those 3 problems, give you like 3 minutes, and then we'll go through the answers. Then I'm going to remind you about the fundamental theorem and how that works, and that will be the wrap up for today. I have an assignment. I will get it posted, and I'll post this video as well. I'm ready to post the answers to assignment 2, so if you were thinking you were going to turn assignment 2 in, you better do that because I'm going to get the answers posted. And once I do that, I'm not going to take assignment 2. And then probably by the weekend, I'll get assignment 3 up and to post. So if you're thinking about you're going to do these assignments to demonstrate your work and qualify for some kind of improvement in your grade for the year, yeah, you need to complete the assignments. And if you're not doing that, then your grade is gonna just gonna stay where it is. Okay, so let's do a quick review / practice. I'm gonna throw our new guys in here. So let's do the antiderivative of 8e to the 2x. Let's do the antiderivative of, here comes the mower, 6x to the 1/3 plus 2 over x. And let's do the antiderivative of 5 minus 4e to the negative 3x plus 5x to the negative 1. All right, setting my timer. Setting my timer. Do a 3-minute timer now. Start. Okay. You're here. Let's see if you can do these 3. I know it's hard. You can't really, well, if you've been writing things down, you can look back. Not sure. Remember, that's kind of the cool thing about doing this on video is even though we don't get like the same kind of interactions, let me put hand sanitizer on. We don't get the same kind of interactions. You are still able to later on look back and see. Look at it, who's all here. Look at all you fun people who are here. Hi, everybody. Hello. Everybody's here. Everybody's happy. It's a lot of people. Saw some of you guys on the teacher appreciation stuff. Thanks for that. Oh, I wonder if I am not showing. Oops, I'm sorry. I think I messed that up. Let's go back. There we go. Okay. So some of you guys saw you on some teacher appreciation videos. Thank you for that. I appreciate you appreciating us. SGA, everything you guys are doing. That's very nice. Lots of fun. So I know I should be doing something for my little boys' teachers, but I'm not sure what we're going to do, how to do it. But one of his teachers, he'll have the same teacher next year because it's his special education teacher, and he'll have him for her for grades 3, 4, and 5. So I can hook her up and hook his 8 up next year. Or maybe this summer if he does some summer school. So he is so not doing this. He is not into, he likes to talk to his teacher, but he doesn't really want to do anything. He just wants to like show her his toys and wave to her and make faces. He just likes to look at himself talking to her. He doesn't really want to do any work. So we're struggling. We're all struggling, doing the best we can because we got no other option. All right, so we're doing these 3 to practice. I'm going to go over these 3, and then I'm going to remind you how fundamental theorem works, and then we should be ready to rock and roll. That should be it. So let's see what we do with this. It's weird to be in my basement talking to myself. Talking to myself. Okay. So I'm going to dismiss my timer. All right, so here we go. I'm going to squish my answers on here. So this first one, 8 e to the 2x divided by 2 plus c, or 4e to the 2x plus c. So one of the things you can do, and this is one of the, if you were taking a test on this, I would say, okay, how do you know if that's the answer? Well, think about what you would get if you took the derivative of that. If you take the derivative of 4e to the 2x, it's 4e to the 2x times 2. And the derivative of a constant is 0. And so you would end up with 8e to the 2x, which is exactly what the original problem was. So that's kind of how you know if you're right. But unfortunately, that also takes you being able to take a derivative. So derivative of your answer gets you back to the original function, then you know that antiderivative answer is right. Okay, number 2. That's going to be 6x to the 4 thirds divided by 4 thirds plus 2 natural log of x plus c. Now that's kind of messy, so I'm going to come down here. How about we'll change that 3/4 times 6x to the 4 thirds plus 2 natural log of x plus c. So how about we can clean that up a little bit to about 9 halves x to the 4 thirds plus 2 natural log of x plus c. That would be our nice cleaned up answer. Everything right here, mathematically accurate. It's just 6 divided by 4 thirds, nobody's favorite. So 6 times 3/4 comes out to be 9 halves or 4.5. I mean, if you did that on your calculator, 3/4 times 6, you would get 4.5. All right. All right. Last one. I'm gonna do a second page. I know that's probably kind of little, but then I can see it and then I can make it bigger. Okay, so number 3. So number 3's answer is going to be 5x minus 4e to the negative 3x divided by negative 3 plus 5 natural log of x plus c. Whoa. Okay. So how about 5x plus 4e to the negative 3x over 3, because the negative over the negative will make a positive, plus 5 natural log of x plus c. Okay. Remember that anything that we go over in class, you can always come into office hours. Let me just zoom that a little bit so it's a little better. And ask about office hours Wednesdays from 11:30 to 1, Fridays from 11:30 to 1. If that doesn't work, you can always just let me know, and we can set something up if you want to go over anything, if you're, feeling like you want to make sure that you are doing these things correctly. Okay. Okay. So we're almost done. What do we have left to do? Well, we're going to review fundamental theorem. Okay. So what was the fundamental theorem of calculus, or FTC, about? Okay. That was the theorem that said if I was wanting to get an area, an integral value, I could use the antiderivative of the function in the integral and evaluate that antiderivative at b, evaluate that antiderivative at a, and subtract those. That was also the quiz we would have had on that Friday the 13th. This was one of the problems, or one of the types of problems that were on the quiz. Calculating the values of integrals using fundamental theorem. So using the antiderivative, substituting those numbers in. Now, if, depending on what our function is, let's just do something basic. All right. If our function is kind of just, polynomial terms, then okay, our antiderivative work is our normal work. And I'm sorry, I just made this a lot harder than it needed to be. Kinds of fractions. We could put the plus c. It doesn't really, we don't necessarily need it so much when we're doing a fundamental theorem problem. Okay. But then I'm going to take this, and the math I have to do is I've got to plug 2 in for x, and I've got to plug in 1 for x, and I've got to subtract those two things and get a value. Some of you kind of got some calculator shortcuts for this, which is, there's nothing wrong with that, but when we were quizzing this, if you were like, I'm just going to use shortcuts, I wanted to see the derivative, and I wanted to see some evidence that you understood how to use the fundamental theorem. Okay. So finishing this one, like I said, I didn't mean to make this into like such a long fraction fun problem, but hey, whatever. Okay. The c's will always subtract away. So let's see. We're going to get a 7/3. So that's the 8/3 minus the 1/3. We're minus 10. We have a plus 5/2. So, you're killing me, Smalls. 14/6 minus 60/6 plus 15/6. Let's make sure I did that right. Times 2 times 2 times 3 times 3 times 6 times 6. So there's a 60 and there's a 29. It's good to do actual math sometimes. There we go. Blah. Okay. Sorry about that. That was a little uglier than I meant it to be, to practice the skill, but it's the skill. Even if the numbers are kind of creepy looking and scary and fractions and blah blah, which you have a calculator, so it doesn't make things that hard. You can do the arithmetic on your calculator. The idea is antiderivative, numbers, top number substituted in first, bottom number substituted in second, result of the top plug-in minus the result of the bottom plug-in. I'm hoping that that's right. I'm gonna grab my calculator real quick and just double check myself. Okay, so 8/3, oops, not 83, 8/3 minus 10 minus 1/3 plus 5/2. Math, frac. Oh yeah, I'm the man. Okay. Now, if we have our new functions, we're almost done. If we have our new functions, let's do just like that. Okay, and let's do e to the 2x minus 3x to the negative 1. Okay. So our antiderivatives, we have to use our new rules. So this would be e to the 2x over 2 minus 3 natural log of absolute value of x. And then we'll be evaluating that from 1 to 2. So we're going to get some crazy answers. I'm totally fine if you just leave the e's and stuff in your answers and the natural logs, or you can use your calculator. I'm going to do this without a calculator right now. So this will be e to the 4th over 2 minus 3 natural log of 2 minus e squared over 2 minus 3 natural log of 1. I guess technically I don't write x, right? The absolute value of 1 is 1, so I just write a 1 there. Okay. Now, if we were writing this out, the natural log of 1 is 0. A little pre-calc there. So e to the 4th over 2 minus 3 natural log of 2 minus e squared over 2 would be a version of the answer. Obviously, calculator work here could also get you some stuff. So yeah, when we have the new antiderivative stuff, since I have e's, we're going to get e's in our answer, and if I have x to the negative 1, we're going to have natural logs in our answer, so some of our answers are going to look a little intimidating. Right? But that doesn't mean we can't do it. It doesn't mean that we can't follow the rule, follow the process. Antiderivative, substitute in the top number, substitute in the bottom number, and then subtract the results. So what I have planned kind of going forward as we work our way through May is we're going to look at some more applications of integration. That's kind of where we were. We had done a couple applications of integration. We're going to review that and look at a couple new ones, and that's going to kind of take us through the final weeks of May. So once again, I appreciate you tuning in, I guess is the what to say. Let me go ahead and go here and go here. I hope you all have, what if I click, oh, that's not what I meant to do. Sorry, that's not what I meant to do. I hope you all have a great day today. I think that's going to wrap us up for today. So have a good morning. Hope you have good classes today. Let me know if there's anything you need from me to help you out. So work will be posted. So ring, I need a bell. You're welcome. You're welcome. Thank you. Thank you guys for being. I appreciate it. Bye. Go get some more coffee. That's what I'm going to do. Let me know if you need something. Bye. Bye. You're welcome. You're welcome, everybody. Have a good one. Have a good morning. Bye. Just me. Just me.